scikit-learn, I'll try to import the built-in data set. Remember guys, the scikit-learn by default sklearn data sets. Okay, so sklearn provides many data set. They're called as a toy data set. Okay, so you can always use any of this data set probably to build your machine learning models. The one which I'm using is the IRIS data set. Okay, the IRIS data set is a data set. So that's basically used for classification, also for the clustering purpose. Okay, so I'm going to say something like IRIS flower data set over here. And if you just scroll it down, so you can see that there are different species of IRIS, such as Setosa, versicolor, and virginica. So based on this, guys, data set, we try to perform the classification, right? Iris setosa, Iris versicolor, Iris virginica over here. Okay, I can also see the Python code over here written in R, but any of these different species have got different features to consider. So I'll say that it's going to be like Iris data set, Iris flower data set. Try to go to the images over here. What you can see is something like this, guys. If you just observe over here, so this flower is associated with petal and sepal over here, petal and sepal. So there will be a petal, there will be a sepal, and we have different features for this different species based on the sepal length, petal length, based on the sepal length and sepal width, petal length and petal width. Okay, we try to see what is the species it belongs to. It could be Iris setosa, versicolor, and virginica. This is a very old data set. It's a very old data set, and it is a good data set to start with. Okay. Now in this case, you can always see that even in this one, there is a petal length and there is a sepal length, and we have different features like sepal length, sepal width, petal length, petal width, and we have a classes for that. Based on this feature values, we try to consider the classes. Okay, it could be the setosa, versicolor, and virginica. I have used the same data set from your scikit-learn. Okay, so importing the data sets from scikit-learn, from sklearn import data sets. Okay, so trying to import this data sets from scikit-learn. After you're done with the importing, you should always try to load the IRIS data set, because we're trying to import multiple data sets. I'm going to import this data sets. Okay, use this data set dot load IRIS function over here. When I use this data sets dot load IRIS, so this will basically load the data into my data variable. So that's basically your data. And if you want to see the description of this data set, you can always use an attribute like data.describe over here, guys. Okay, so once you're done with the loading of this one, you can always say print of data.describe. Execute this. What you can see is like the description about this data set, saying like number of instances. We've got the 150 instances and 15 each class, each of the three classes. Nothing but Setosa has got 50, versicolor has got 50 instances, and virginica has got 50 instances. And the attribute informations are like this: sepal length in centimeter, sepal width in centimeter, petal length and petal width. And this is like the correlation between these different features over here. Okay, the class correlation. So sepal length with respect to the class. Okay, and what is the correlation you can see in sepal width with the correlation with the corresponding class and the species classes, and petal length and its correlation with the class, and petal width and its correlation with the class. This seems to be really high. Petal length and petal width definitely help us to classify this flowers into different species. And we have got a maximum, minimum, and then standard deviations and the class correlation column over here. So if you just observe over here, this is basically created by Michael Marshall in the year 1988. Okay, so this is all about the information what you can see from this particular data set, guys. Okay, this is kind of hello world data set we normally use. But remember, certainly we can make use of any data set to build your decision trees. Okay, now I'm going to split this data into two parts. One is like the X and another one is like the Y over here. In this case, guys, since I have only 150 records, I'm not going with the train and test split. If you wish to go with a train test split, you can always go with the train test split. Okay, I'm actually going here, but certainly sometimes I do not go with that process. Here in this case, I'm going with that splitting. X is like data of colon, comma 2 and 3. So from this data variable, okay, from this data, what whatever you have chosen, okay, you will see something like this. Okay, if you try to print this data over here, it should look like this. Okay, so we'll have this column values. Okay, so nothing but two-dimensional array. Okay, and if you check with the data dot features over here, so it's going to be like data dot feature names. You can always get the feature names of this. The feature names in the order is something like this, guys. It's going to be like sepal length, sepal width, petal length, and petal width. That's basically printed using this data dot feature names. Okay, so you can always get the target names over here. Say something like target names over here. What you can see is the target names. Okay, just see something like that. What you can see is target names are nothing but the species of this iris flower like Setosa, Versicolor, and Virginica. That's basically how you try to check the built-in variables already available with the scikit-learn. Okay, not really required always, but we can certainly make use of this in our tree visualization. I'll scroll it down, and then I try to split this data into two parts. One is X and Y. Take the data, say data dot data of colon, comma 2, comma 3. Consider all the rows and select the two columns 2 and 3. Remember, you guys, since I wanted to visualize the decision boundaries, I'm choosing the 2 dimensions over here. Remember, when you want to train your model, do not only stick yourself to the 2 columns, whatever you have chosen. Reason for choosing the 2 columns is because I'm using some package or some library in future. Those library will only support the 2-dimensional values. That's why I am trying to make use of this 2 and 3. What is it, 2 and 3, guys? It's all about your the 2 feature names over here. That's basically your petal length and petal width, because I felt that those are the ones which has got a very high correlation with the class, species class. Okay, it means that this is 0, this is 1, this is 2 and 3. So last 2 columns will be selected, and those 2 columns are written something like this. Select all the rows and then select 2 and 3 over here. Okay, so just slicing it and try to keep it inside your X. And I also want the target. So remember, target names is different from that of target. Y is equal to dot target will give us all the target values, nothing but your species values like Setosa, Versicolor, and Virginica. Okay, when I try to check with that Y, as it's a method to load the iris. Yeah, so similar way, you also get the other methods. Okay, load digits, load diabetes, load Boston. In terms of method is being used. So in this case, guys, you can see over here, this is like the different species, Iris setosa, Versicolor, and the Virginica. They're all labeled over here. That's what I'm trying to choose by just saying that data.target. Data.target will give us all these values, and then we want to store that inside Y over here. Okay, that's basically your Y, what you can see in this particular cell. X and Y. X is having 2 columns. One is the petal length and petal width. Your Y is having the last column, nothing but the target over here. Once you're done with the splitting, guys, remember this is a built-in data set. Okay, so there will be no missing values. Okay, there will be no missing values. The statistical information is already given in the describe section of your this particular data set. I'm going to make use of this X and Y so to build the decision trees, and we'll try to visualize the things. That is the agenda of this particular notebook. I'm going to say something like this. From the family of tree, okay, say something like from scikit-learn.tree, import decision tree over here, decision tree classifier over here. This is basically from the scikit-learn's family of tree package, and that will be like decision tree classifier. Try to execute that. Okay, so you're done with importing of this. Now, in this case, guys, I'll have to tune your model. There are so many parameters associated with the decision trees. Remember, if you do not set a random state in your decision tree classifier method, you start getting the different trees every time you execute the cell. I want to fix that problem. So try to obtain the same tree, the same tree structure with the same attributes every time you execute this, or multiple times execution of the cell. You'll have to set this random state. Say something like model is equal to decision tree classifier of random state. I'm setting it to some random value, which is basically 1 here. And I'm setting this max depth is equal to 2. What is the max depth is equal to 2, guys? As I told you earlier, so there will be always the depth associated with the trees, and that will actually control the depth of the tree. Okay, as you increase the depth of the tree, your model tends to overfit. That is also one problem that you should read. That's called as unpruned trees, what we discussed earlier. But again, if I'm trying to set max step is equal to 2, but really just remember this point. This is like randomly or like blindly I'm setting this max step is equal to 2. I really do not know what is the best optimal max step to set for this particular data set. I'm setting max step is equal to, you can set it to maximum values. Remember, the max step for this particular data set is enough, like 2 or 3 is enough, because we have got only 4 features here. If you have many features, you can also try to increase the max step. Okay, probably to 7, 8, or 10, something like that. Okay, but now I'm saying that its max step is equal to 2 and then random state is equal to 1 over here. So that will basically initialize your model with that random state 1 and max step is equal to 2. I'll try to execute this one. Okay. Once you're done with that, I'll try to check what is your model. The model looks like this. It's basically the max step and random state is equal to 1 over here. We're done with initialization of the model. Then you'll have to know, you can, before only you can split it, maybe after initializing the model, I'm trying to split it. I'm trying to choose this train test split from your model selection family of your scikit-learn. And what I'm trying to do is that I'm trying to split this data into train set and test set. 80% I'm keeping it as a training set and 20% keeping it as a test set over here. And setting the random state for this train test split is different from the random state for this decision trees. The reason for setting this random state for the decision trees or any model is because I want to generate the same decision trees every time I try to execute this cells multiple times. Whereas in this case, I want to generate the same shuffling. That's why I'm setting the random state is equal to some random value. That's basically your 100 in this case. Okay, I need to actually pass this x and y, whatever I've taken here, x and y to this particular model. Let's say that train test split x comma y, set the test size is equal to 20, random state is equal to 100 over here. That will basically resolve all this variable, which will basically have the x train, x test, y train, y test. Say something like xtrain.shape and xtest.shape. Out of 150 records, if you're trying to choose 80% of it, then basically what you can see, excuse me, I need to execute this one. Okay. What you can see is like out of 150 records, 80% is basically your training data, nothing but 120. And then 20% is nothing but 30 over here. That's basically 2 columns and then 128 records and then 2 columns and then 30 records over here. I want to fit this model with the train part. Okay, that's basically your x train and the y train over here. For that, I'm going to say something like model.fit of x train, comma y train over here. So try to fit that model with x train and y train. What you can see is like your model has been trained internally. You're also trying to create some decision trees. Okay, but in this case, guys, after you have trained your model, you can always perform the testing on this test data. So which is nothing but your x test over here. So say something like model.predict on x test, which is your 20% data, and store all the predictions inside your prediction variable and try checking what you have inside this prediction variable here. Try to do that, you will get the predictions for all those 30 records, whatever we have splitted earlier. That's basically your 30 predictions what you get over here. Here comes a very important part. We wanted to understand, theoretically we understood how this decision tree basically works. But we wanted to see how this splitting is done, okay, by your scikit-learn internally. Of course, it uses this Gini index. You can observe over here, guys. When I try to use this decision tree classifier over here, you can always see that the criterion used is like the Gini over here. That's basically how you try to create a decision tree using this attribute selection measure called Gini criteria, attribute selection measure or criterion called Gini, which is always by default used by your scikit-learn. Now it's time to install this MLXtend. It's called as a machine learning extension library, which is a third-party library. I'm going to make use of this third-party library because I just wanted to see how this decision tree boundaries are created. I expect all of you to install this MLXtend, which is going to be a third-party library that you can always get from this particular website called MLXtend. So this is basically your MLXtend. Okay, so MLX third-party machine learning library you can always use to create some decision boundaries like this. Okay, this is the one that I'm going to use. You can always install that by saying something like pip install MLXtend. So let me know once you're done with the installation of this MLXtend. I've already done with the installation of this MLXtend, which is nothing but ML extension libraries. Once you're done with that, please let me know in the chat box. Let us proceed with the next code. Okay, just try to say shift enter here, so it will get automatically installed, guys. Okay, you guys already done, I think. Cool. So it's already installed, right? Cool. So now I am basically considering how about others? How about others like Preetham, Rupali, and then SC, single, and then I'm really sorry, I'm not really getting. Yeah, cool. I think most of them saying how about Abhishek and Debasish, Joseph, they're all done. So now I'm going to make use of this one, guys. Let's say that I'll use this ML extend library from this particular third party. It's like GitHub like rasbt.github.io over here. From this one, I'm installing this ML extend. Here in this case, I want to see the plot decision tree region. For that, I'm going to say something like from ML extend plotting, import plot decision regions over here. So from ML extend, you'll have to call this plotting and then import plot decision region. I'm going to execute this one. That's basically how we try to import this plot decision regions. Once you're done with it, guys, reason for taking the two dimensions is because I just want to visualize that regions, plotting regions. Now I say something like this, guys. I'll try to use this function like plot decision regions, pass in your training set, because these are the parameters you'll have to pass, like X train and the Y train, and the model that you have created earlier. Okay, nothing but the model, the decision tree model we have created earlier over here. When you try to pass that to this plot decision tree function, and then set your X label, set your Y label, and location. Legend location is basically your lock is equal to upper left. That's basically upper left over here. And I want to save the figure. For that, I'm going to say something like pl.save fig of decision trees. If just observe over here, guys, I'm trying to plot this decision or plot decision region using these two dimensions like petal length and petal width over here. These are the values of the petal length and petal width over here. What I can see is like the different species and how these are being like, we have created the decision boundary for the different species. Like this is your Setosa and then versicolor and the Virginica over here. You can always see this. I'll come back to this one, guys. Okay, so just plot this. Once we plot the tree, then we can come back and then we understand how this decision boundaries are created, how this splitting is basically done. Okay, so now I'm going to shift myself to this tree over here. So say something like from scikit-learn tree package, you can always try to plot the decision trees or visualize the decision trees. I'm going to say something like this from sklearn import tree. Just try to import it, and already it's been visualized. Okay, what I can say, you can always use this plt.figure and set the figure size with the width and the height 25,20 over here. And this can also be this is basically taken from the scikit-learn one, guys. Now I'm not doing any thing special over here. Scikit-learn tree plot over here. This is perhaps taken from this scikit-learn documentations only. I've taken from this documentation and tried plotting this tree. That's it. Okay, so from this one, okay, simply say scikit-learn one y. Okay, so I'll just try to go with this one. This one you're asking me. I'll come to this point. I'll come to this decision pre-plotting once we understand this. Okay. What's there in the code even? X label, I'm setting it to Y. Plot decision region, X train, Y train. You mean you're asking me see, this is regardless of whatever you're trying to keep it on your X-axis and Y-axis, you'll have to try to say X train, the Y train, okay, and the model over here. That's it. There's no relationship between this and this. Why this one you're asking me, the Y label you're asking me? You're trying to create a decision trees. Okay, I'm not considering the Y. I want to see how these decision trees or regions are created using two features. That's it. I'm not using the last column, which is a Y column over here. I want to see how these decision trees are created using the two features. This can be easily understandable by just visualizing this tree. I'll come to this one. Okay. Observe here. I'm trying to set the figure size over here, 25, 20, and then there is a garbage variable here, guys. Underscore is called as a garbage, which is not really required. You can always say it's kind of like tree.plot. Garbage variable are always used to store this variable visualization. So till you execute this particular, complete this, terminate this Jupyter notebook. Okay, it's called as a garbage variable. You don't have to worry about it. But you can always try to use this tree.plot tree, and to this plot tree function, the parameters that you need to pass is like the model, and you need to set the feature names. What are the feature names we have used here during the training phase? The petal length and the petal width. And the class names are like Setosa, Versicolor, and the Virginica. And then label is equal to all, nothing but if you want to see the labels or the details inside this each node. And filled is equal to true, nothing but filled with some colors. And then rounded is equal to true, nothing but you can see the shape of this, boxes over here. It's like smoothen at the border over here. That's basically rounded is equal to, which is not really required. This is all about the formatting of things. So try to execute this one. What you will see is like a decision tree, something like this. Now observe here, guys. If you just observe this one, the petal width is less than or equal to 0.8, and Gini value, what you're getting for this is 0.66 value, 665. And basically we're trying to train our model, decision tree model on this 120 samples, 80% data. That's why you're seeing that 120 as a number of samples. And the value has got the list of values. 39, 44, 37 over here. That's basically the Setosa, Versicolor, and the Virginica. If you just observe over here, we are setting the class, the majority class over here. Your decision tree is considering the majority class over here. So 39 is out of this 120, 39 is basically the Setosa. And then 44 is your Versicolor, and 37 is basically Virginica. The class is equal to Versicolor because we have got 44 in this case. It is just showing that the majority classes over here, the majority of instances which belongs to Versicolor. So in this case, guys, so the purity what you get is 0.665. Now we further split it. Let's say that how this is basically splitted. If you just observe here, the petal width is taken something like this, less than or equal to 0.8, setting as a threshold value over here. Just go back to this one and check with your threshold values over here. What you can see in this example here, is the petal width less than or equal to 0.8. We just observe the plot decision regions here. So go along the y-axis. What you can see on the y-axis like 0.5, 0.6, 0.7, 8. So this one is a boundary that we've created. And if you just try to plot this boundary like this, okay, so along this petal width, along this y-axis, what you can see is that some points are like coming in the blue region, some points are in the orange, and some point in the green region. In this case, the Setosa is really far away from this Versicolor and the Virginica. It means that when you try to visualize this Versicolor and Virginica seems to be very closest to each other. Maybe their petal length and petal width are similar in terms of their length and width. Okay. Now the Setosa is really far away from this. That's why we're setting that it's like petal width less than anything which comes below this petal width like less than or equal to 0.8. So I would get this Gini value over here and then the value of something like this. Now in this case, guys, if you just observe over here, so all the blue points are coming in this region. So in this region, you see only the Setosa over here. There is no mixture of classes over here. That's why I'm going to call that as the leaf node. That will basically give us a Gini value 0. And the samples that you consider is 39 in this case. And once you consider 39 as a subset value, the value will be equal to 39. And we are considering only the Setosa over here. It's a pure partition. And 44, 47 will be taken this in the right hand side. That's basically 39, 0, 0. And what you see is the class here is Setosa over here. That's basically considering this threshold 0.8 below that in this region over here. Now, I'm also trying to check with another petal width threshold over here. So petal width is basically less than or equal to 1.65 over here. So 1.65 over here, that's basically in this case, guys, trying to create one more decision region somewhere in this region. So trying to split your Versicolor and the Virginica. We tried splitting this Versicolor, but some points, some Virginica are getting mixed with this Versicolor, and some Versicolor are going border of this Varijnika. That's okay. But what you can see over here is something like this. The Gini value, what you get for this is 0.496, and number of samples like 44 plus 37, you'll get 87. Out of that 81, if 81, the number of values are like 0, 44, 37 over here. Okay, so majority of them are versicular. Still, we are not getting that kind of pure partition. We expect to get a pure partition. Okay, I further go and see something like this, guys. Okay, consider this again split. Okay, because you can see some points are like coming inside your versicular region. Okay, so for that, I'll say something like Gini is equal to 0.156 for the splitting this one. And what you can see, out of this 47 samples, out of this 81, we take this 47. So majority of them are belonging to 43, and then a couple of them are belonging to the Varijnika, even in the split. This is okay this is okay. We are not actually overfitting ourselves. We are not going with a pure partition every time. 43, imagine that this is the number of observations what you see in this versicular region, and a couple of points are inside this versicular region. That's basically your Varijnika. That's why you're seeing something like 43,4 over here. For few samples, majority of them basically versicular. I'm going to set the class is equal to versicular, but you know, if you can observe over this Gini value, the right hand side, Gini is equal to 0.057. Number of samples that you left over, so out of this 181 is like 34, since you have already taken this 47 over here. So you can see that in this region, your value is equal to 0,1,33. One is only, I think one, if you just observe, one is actually falling in this, somewhere in this particular region. Just observe that. So nothing but versicular is going to the Varijnika region. That's why I say that one over there, but majority of them are basically the Varijnika. That's why you want to set this class is equal to Varijnika in this case. Okay, so it means that the 3 is basically taken considering these different threshold values, okay, in scikit-learn. And then this is the reason that I have taken this decision plot region to understand this different threshold values in this case. Okay, that's basically how you try to visualize the things. But remember, this is one way to visualize the decision trees, but you can also visualize the trees in different ways. Okay, let's say that you can always use the different packages to visualize the trees. The one I'm using is the tree package, but there is also something called as a Graphviz. Okay, that I would like to share even that. Okay, there is something called as a Graphviz. Graphviz, okay, to visualize the trees over here. Okay, so Graphviz, okay, to visualize the tree. You can always consider this Graphviz. Okay, so I think MLJAR is a great site where you can always try to see the different ways of this plotting these decision trees over here. Okay, you can always look into this block and check how this decision tree can be plotted.